Today, in this video, we are going to discuss something called rationalizing denominators. And I'm going to start this conversation with an instruction. So it's going to lead us to the right thinking that we have to do. So here's what I want you to do. Change the fraction so it has the new denominator shown. All right, so I'm going to give you a few different fractions. We'll start with the fraction 2/3. And I want you to change it so it has a new denominator. I'll give you that denominator. And for this one, I want it to be 6. So what do? We're always looking at the how the denominators changed through the lens of multiplication. So we're going to multiply. 3 times 2 is equal to 6. So we change the numerator accordingly. We're multiplying by the same constant number here and here, which means this would be 4/6. So that would be our new fraction. Let's do another one. Let's do the fraction 4/5. And I want that to equal something over 25. So I notice that I multiplied the denominator by 5, which means I have to multiply the numerator by 5, which would give us the fraction 20 over 45. Okay? Well, we are in the mode of talking about radicals recently. So what if I give you the square root of 2 over 6? And I want to change that to be something over 42. Okay. Well, across the bottom, this denominator was multiplied by 7. So I would have to multiply this by 7. Notice how this is in the radical and this is not. So we write it as 7 radical 2. We keep them separate and we put this out front as the coefficient. So this is what that new fraction would be. What if I give you a denominator or a fraction that has a binomial in the top, like x plus 3 over 7? And my only instruction is change that so it is a fraction with a denominator of 70. Well, let's see. You would notice that you're multiplying 7 times 10 to get 70. So we have to multiply the numerator by 10. But we don't want to just write it like this. We need to distribute that 10. We need to multiply the whole thing by 10, not just one of the terms. So this would be distributed to be 10x plus 30 over 70, multiplying 10 by both terms. Well, now I'm going to give you one that is the start to the thinking that we will be doing in this this lesson, this video. 5 over, let me do a better radical, 5 over radical 2. I want to change that to be something over 2. So we went from a denominator of radical 2 into a denominator of 2. So how do we do that? Can you figure that out? Well, what would we multiply the square root of 2 by to turn it into the number 2? Can you figure that out? Can you think through that? Hopefully you came up with, you would multiply it by the square root of 2. You might be wondering why that is, because if we take radical 2 times radical 2, what do we get? Radical 4. We actually multiply the numbers in the radicals. And what's the square root of 4? 2. So we have to multiply the top by radical 2 as well. So what does this give us? Well, we just write it as 5 radical 2. So we went from 5 over radical 2 to 5 times radical 2 over 2. What we just did there in that thing was we rationalized the denominator. Rationalized the denominator. You might be wondering, well, what does that mean? What did we actually do? What it comes down to is This number down here, the square root of a non-perfect square, is what's called an irrational number. Irrational numbers are numbers that can't be written as fractions. We often view them as decimals that go on forever and never repeat. Here's what a decimal approximation of the square root of 2 is. Notice how there's no repetition, and this technically just goes on forever. We don't like to have irrational numbers in our denominators. We like to have rational numbers. Rational numbers are any number that can be written as a fraction. They're numbers that if you make them into a decimal, they either repeat or they stop, like the number 2. I much prefer to have a nice, neat whole number than an irrational number. So the way that we do that in this video is we're just going to be looking at having a single radical down there. And the way that we do that is we multiply it by itself. And we do it on the top and bottom. And then we simplify if possible. So let's do that. Your instruction is simply to rationalize the denominators. I was going to write it. I was going to type it, but that doesn't look like it's going to work well. So I'll just say it. Your instruction is to rationalize each denominator. So let's start with this one, 9 over radical 3. So we multiply it by the square root of 3 over the square root of 3, right? Whatever this is, we multiply by itself, and then we do the same thing on top. So what do? We've got 9 radical 3 on top. On the bottom, we have radical 9, but we know we can take the square root of that and get 3. And we get 9 radical 3 over 3. But we always look to see, can we simplify things? And what hopefully you'll notice is that this number on the outside is equal to 3 times 3. And then, as we've seen in other lessons, we have a common factor on top and on bottom that can be canceled. So all we are left with is 3 radical 3. 3 radical 3. And there's nothing on the bottom. This is all that we have left. Next one. Let's do 5 over radical 5. Take a moment and try this on your own. I'll keep going. We multiply by radical 5 on top and on bottom. On top, we have 5 radical 5. On the bottom, we have the square root of 25. Again, 5 times 5. That denominator can be simplified to be 5, and then these cancel, and all we're left with is radical 5. Next one. How about the square root of 3 over the square root of 7? So here we notice that there's radicals on top and bottom. When we're rationalizing denominators, we don't care about radicals on top. Those are fine. We don't like them on the bottom. So we're going to multiply it by radical 7 over radical 7. All we care about is this one. So in this numerator, we're going to have the square root of 21 because they're both inside radicals. So we multiply them and keep them in the radical. On the bottom, we have the square root of 49, and we can simplify that. Radical 21 over 7. The square root of 49 is 7. You might be wondering, can we simplify the 21 and the 7? No, because 21 is in the radical and 7 is not. You might look to see, can I simplify the radical 21? And the answer is no. There's no perfect square inside 21. So this is as far as we can go with that one. How about the square root of 3 over 2? Here I put a radical over both the numerator and denominator. Well, we actually saw previously that those can be separated. If you have a radical over an entire fraction, you can separate it into 2 radicals in that fraction, one on top, one on bottom. And then we multiply both sides by whatever that denominator is, radical 2 over radical 2. On the top, we'll have a radical 6. On the bottom, we will have radical 4. We take the square root of that denominator to get 2, and we're left with the radical 6 on top, which cannot be simplified. So that is it. What if we have a variable in there? What if we have the square root of w over 3? Well, just like before, separate it into 2 separate radicals, one on top, one on bottom, and rationalize the denominator, times radical 3 over radical 3. The square root of 3w on top. On the bottom, we have the square root of 9, and that can simplify, and the top cannot. On the bottom, we take the square root of 9 to get 3, and we're done. Okay, try one on your own again. What if we have the square root of, let's go 3x over the square root of 2. Try that on your own. Again, square root of 2 over the square root of 2. That's what we're multiplying by. Here we have the square root of 6x. Again, on the bottom, we have the square root of 4. The bottom can be simplified. The top cannot. The square root of 6x all over 2. And let's do one more of these. Let's do 8 over the square root of 7y. So try this on your own. I'll keep going. So it's the bottom we care about. We'll multiply it by the square root of 7y, square root of 7y. So on the top, again, we have a coefficient of 8 and 7y on the inside over the square root of 49y squared. That can be simplified to be 7y. And on the top, we have 8 times radical 7y. Now, again, this and this, the 7y's, one's in a radical, one's not, so they can't be simplified any further. So that's the basics about what it means to rationalize a denominator. That's going to occur when you have radicals in those denominators. You want to eliminate them.